Hello, welcome to Fresh Concrete. This is just one of a series of talks and recordings that have been created to share some of the wide-ranging innovative practices and new types of concrete emerging to address climate change. Now, these are technologies that bring a fresh approach and fresh thinking to the way that we make and use concrete. My name is Elaine Toogood. I'm Director of Architecture and Sustainable Design at the Concrete Centre, and I'm going to be introducing today's presentation, produced in collaboration with the Concrete Centre and the Building Centre. Now, this talk is one of two that were selected following the theme of innovative concrete manufacture. And we're delighted to be joined by Phil White, founder of Cloud Cycle. He's going to be giving his talk called Digitised Concrete. So that is Cloud Cycle's intelligent, in-transit, real-time concrete management system for ready-mix concrete. Now, the development and use of digital technology for fabrication has been described as a third revolution. And I think it's true to say we are just at the beginning of our understanding of how to utilize digital technology, the opportunities that it can bring, along with artificial intelligence, the impacts, the potential impacts on design, manufacturing, construction for all materials, but also cement and concrete. They include virtual and mixed reality tools and design software to help us design complex shapes and structures and formwork systems. Many of these tools are already available within practices today, but also then the connection between those design tools direct to the manufacturing process. New tools enable to be able to make those complex forms and shapes much more efficiently than we previously would have needed to be relying on expert craftsmen to do these individually. And what excites me about these processes is the opportunity to bring more elaborate forms and repetition and efficiency to bring more decoration and interest into the built environment than we might normally have been able to do. Of course, 3D printed concrete falls into this category, and we have had a presentation of Fresh Concrete about this already explicitly, but it's also not just about 3D printing, but other forms of automated manufacturing and construction systems and processes, whether that's within a precast factory or on-site, lots of opportunity. So digital technology is definitely an enabler for current future technological development in the manufacture of concrete and cement, not only for changing the potential aesthetics, but also in creating greater efficiency, avoiding waste, but also significantly capturing and sharing data, which of course is critical for carbon reduction and circular economy and improving quality right the way through. It's a great virtuous circle there. And within this data sharing comes intelligent cloud-based systems able to monitor and control manufacture and delivery of materials for construction. And we are going to learn today much more about specific systems available for use within ready-mix. This is our main presentation. So over now to Phil White from Cloud Cycle, as I said, who's going to be giving his talk about digitized concrete. Over to you, Phil.
Thanks for having me. Great to be here. So yeah, digitizing concrete. It's a very broad subject, and like Elaine said, what we want to try and do is have the sustainable ends of where we get to digitization. So if you think about our tool throughout this entire presentation, what we're really here to do is to be a resource efficiency tool. So whether we're making the concrete more resource efficient, you can make it in more efficient ways. You can take the carbon out of the manufacturing process, but if you're still not using it in a resource efficient way, it's wasteful and it costs money. So yeah, there's two elements. There's the concrete resource efficiency, and then there's also the cement resource efficiency as well. So yeah, we'll go through basically this presentation. We'll take you through a bit of this cube system, which is what our system is called. We'll take you through how the digital world compares to manual world in terms of testing. We'll take you through the current use cases that Cloud Cycle is being used for, some future use cases, kind of the traction of who we're working with, who our partners are, and then finally we'll finish off with kind of what is the impact of Cloud Cycle, what is our mission and our vision in terms of sustainability and impact on the industry. Yeah, so this is a high-level overview of the system. Don't get too bogged down in it, don't get too technical, but it's made from essentially a hardware device that goes on a concrete truck, which then feeds a back-end platform, which is able to provide lots of very cool things. So real-time data on a dashboard, reports and insights later on, day +1, at the end of the week, and alerts and feedback to our operational staff on the day to make instant decisions and instant reactions because the alerts are there. And one of the things that we really want to do with Cloud Cycle is make it accessible to anyone and open to anyone. So we built an API, which means that we can plug into any batch plant in the world, we can plug into any concrete truck in the world, and we can plug into any system in the world. So if you're a tier 1 and you're using SAP, we can plug into that, and we don't make you use our front end. We can put all of our data into your existing workflows, so your day-to-day operations don't have to change, but your insights and the data you've got at your fingertips is much greater. But what is our product specifically? So our product involves lightweight hardware that goes on a concrete truck. It's no upfront cost, and what this does, that's the data collection piece that sends the data to the cloud. Once it's in the cloud, this is where we have kind of our smarts and our secret sauce. We've got data scientists working with concrete experts to build algorithms and machine learning, which does the analytics on the data that we're receiving. And then on the front end, what you get as a customer is all of the insights. And what we're really measuring is concrete quality in real time. So, RMCs can spend millions on batch plants and batch the concrete perfectly. It goes in the truck, ends up to the site and gets rejected. And it's a huge problem in the industry. Around 5% of all concrete is rejected. And the cost and carbon implications behind that. But just taking you through the front end here. So this is our front end. So again, all of these things you're seeing on this screen could be pushed into your system that you're working with currently day to day. So we've got a searchable delivery history. So that can be per truck, per batch plant, all the loads that delivered that day, that week, any issues, was there any problems with it, was it delivered in slump, you can check all that. We've got a carbon tracker. So this is the transport phase of the carbon that we're tracking, and we're integrating that into the actual carbon footprint of the product as well. We've got a saying, it's quite popular, if you can't measure it, you can't manage it. So this is really shining the light on the transport phase, as well as the concrete material carbon footprint. Delivery status, where is the truck on the route for operational purposes? We know what the truck is doing in the drum. Is it washing out? Is it discharging? Is it getting loaded? What is it doing? How fast is it spinning? We have all these insights on here. Workability and acceptance, obviously key. We can't be delivering anything that's in the red. Delivery docket information. This comes from our integrations into batch plants. So when we take delivery of a load of concrete in the back of the truck, we feel that concrete and we can assess what it is, but without us being told by our customer what they think it is, we can't match that up and we can't do the machine learning on it. So that's what that is there. And we're integrated into some of the world's biggest concrete companies. And then you have the workability plot here as well. So you can see the curve, it's batched slightly high and it comes down and hopefully it's delivered on site. So it's a good curve and that's what you want to see. And again, what we're here to do is kind of assure every single load of concrete, and we want to see that in the green. And if it ever gets into the red, we can send alerts and cause actionable insights. So the batch plant operator can intervene, the operations manager can intervene. Whoever sees these alerts can really start to reduce those rejected loads, reduce the wastage, and make sure that they have greater assurance on what is going in the ground is within slump. Just to kind of break it down where we are with manual versus digital. Here's a manual slump test. I'm sure many people on this call have done one. It was developed in 1920s and it's just no longer fit for purpose. The concrete material science has moved drastically on since then. Mixers are more technical. They have more parameters. They contain more admixtures, and ultimately concrete can perform better than ever. So the current testing, also in terms of coverage, consistency and transparency, is very, very inaccurate. And we're doing a lot of work with HS2, and HS2 have recognized this. HS2 have said, okay, we want every single load, every single truck tested on our project. Now, obviously, this is hugely expensive. It's slow. Our data is showing us that even manual tests are very inconsistent, and it just doesn't fit into the new digital world. And it's not great when you're only testing 5% of loads, and there's technology like this where you can test 100% of the loads. In terms of numbers for a project like HS2, the numbers are pretty scary. So that's 1.2 million manual slump tests that they will do over the period of that project, which is 100,000 man hours. That's 100,000 hours on site, putting someone at risk when they don't need to be there. And a cost of between 25 and 35 million pounds just on concrete testing alone. And this doesn't take into account the amount of physical concrete that is wasted by doing tests. It might seem small on one test, times it by 1.2 million, it's a lot of concrete that's disappearing. And then what we look at is, what are the benefits of digital testing? Well, they're pretty clear to us. So we can cover 100% of trucks and 100% of loads. We can do a test every 10 seconds, apart from, once it gets to site. And our latency is immediate. So you have the result in your hand as soon as it is delivered. The cost for digital testing is fractional, but there is one challenge, and there is currently no standard for digital concrete testing. So this is one of the barriers that we need to break down for this technology like ours and our competitors to be ubiquitous within the industry. Once you have a standard in place, you'll see productivity go through the roof because people will trust this technology more. You'll see the cost coming down. You will find that you have less technophobes on site because, it's next to a standard, so it must be trusted. It will improve safety by reducing man hours on site. It will give you that golden thread of data from the batch plant to the site and even beyond. So the designers can have access to this type of information to design better. And once you have full data transparency through the supply chain, good things happen. And ultimately, it lowers risk because we're delivering better concrete, which is assured and transparent and visible. We're doing a lot of work with HS2 and Innovate UK through grants. And we're also working with BSI and I3P. If anyone on this call is a member of I3P, we're working with all of these industry bodies to bring in a digital concrete testing standard in the next 12 to 18 months. HS2 have already agreed to accept digital tests in replacement of manual tests, and we're working hard to deploy that and validate this technology, because once it becomes ubiquitous, the cost savings are huge as well as the sustainability outputs. What I'll do now is I'll take you through some of the current use cases. So traceability, what does that mean? Well, providing real-time digital assurance of workability, it really, obviously, it reduces the need for manual testing, and having a digital pour record of the exact location, time, and quality of each pour, as well as its carbon footprint, just gives you the full view of what is happening on site. There are no kind of corners for any data to hide. So that gives you better information to make better decisions. Full integration into customer-facing technologies. This means that if you're an RMC, if you're a tier 1 contractor, if you're a client, you can be assured that everyone is using a single source of truth in terms of a trusted data set. So there's no kind of changing the results of a test. There's no hiding behind anywhere. Everyone is using the same system and they see the same data and it's trusted. And integrating pour records with BIM, we can do automatic as-built updates, and we can work with designers on how the concrete's performing in terms of what they thought the design was, and we can work back from there. So it really opens up this golden thread of data, which gives an opportunity. Internal quality assurance, predominantly for ready-mix suppliers. Really understanding the workability of the concrete in real time. This gives the batcher real-time insights at his dashboard. If there's an issue with the load, what was the problem with it? Well, was it hot? Was it going off too quickly? Was there water left in the truck previous to putting the load in? You can call the driver, you can speak to the driver. So the next batch is always batched better than the previous one. And that's what we're about. We're not kind of about finding out that there's something wrong with the concrete in the truck and then putting an admixture in there to try and fix it. We're about continual quality improvement. So we're batching better based on the conditions around us and based on the condition of the truck that's receiving the concrete. This also enables performance of new mixes. A new admixture comes to the marketplace. How does it perform? We can tell you how it's performing in terms of how fast the concrete's going off. Is it going off slower? Is it going off quicker? And we can compare, different batches, batch plants, different sites compared to how they're making each mixes. And ultimately, it's a quality assurance tool. It enables the quality assurance staff and resources to be where they're needed at what point, instead of kind of doing routine tests where they might not find anything very kind of special. Our system enables them to go, actually, there's something happening on this job site, or there's something happening on this batch plant. Maybe go check it out and have a look there and see if there's something going on. Water addition, this is a huge thing, both on site and from an RMC perspective. It's hugely contentious around who added water when. Our Cube Water Detect feature automatically detects suspected water addition, whether that's through the pipe on the truck with a flow meter, or whether someone's thrown 40 litres in the back with a hose pipe. Our system can detect it. It alerts the batch plant, and it can alert the site manager, because neither the contractor or the batcher want water addition on site that's not authorised, because it affects the strength of the concrete, obviously. And our data is actually currently being used today to defend a water addition claim, because some cube strength tests failed. Usually there would be no kind of defence to that, but with our data and with our technology, our client is successfully defending that by the looks of it. You can understand which sites are adding water frequently, which drivers are actually pushing back against water addition. So it unpicks lots and lots of things that could never previously be unpicked because of the lack of data. Truck driver behavior is a huge one. Are drivers carrying out the right mixing programs for each load? Are they spinning up on site? Are they spinning their drum too fast on the way to site? Risk of rollovers or drum wear out. Are they discharging in the right locations, and are they washing out in the right locations? Are they leaving water in the back of the truck? You've mixed your S4 perfectly, and you put it in the back of the truck, and it arrives a really sloppy, S5 or even a wetter S4. These things happen, and with our data sets, we can help improve all of these issues. Operational excellence. We can track anything granularly. So we can track driver breaks, we can track how much throughput they're doing at the plant. We can reduce the need for phone calls between batch plant and driver. So ultimately what we want to do is get to a point where a concrete truck driver does not have to worry about the concrete. He's not paid to worry about the concrete. Although the ready-mix companies do make them worry about the concrete, they shouldn't have to. We want the driver to drive, pour the concrete, come back to the batch plant, and allow Cloud Cycle to worry about the concrete along with the batcher. The other thing that we can do is monitor site waiting times. These are often in as levies and sundry costs within a contract. If you're there for more than half an hour, you can start charging for that time, and we can start to manage that and work with both sides of that to understand, is the concrete company sending too many trucks? Is the contractor not having good enough site access and egress for the trucks to get through? So we can work through these issues with the data sets that we have. One of the things that we're really excited about is our real-time CO2 monitoring. So we're already live with our CO2 truck monitoring. This includes things like drum speed. You may not think it, but spinning the drum at 10 RPM versus 4 RPM has a huge impact on how much CO2 is coming out of that truck. Because concrete is such a large CO2 emitter, we often get told, oh, well, the transport's such a small part of the supply chain. But if you're a haulier, the transport is 100% of your CO2 emissions, right? And it's still a huge amount compared to most other industries. So we want to really help with each granular level of the system, and then eventually integrate into our customers' data sets and what they're saying the carbon footprint of each cubic meter of their concrete is. And with their information and our information, we can give the customer a carbon footprint of that load upon delivery every time in real time. And that's a really exciting thing for us to work towards. And this will include things like, if it's rejected and wasted, we can understand the carbon footprint of that as well. So we can really get granular and into the weeds on this. And when you're talking about concrete, which is 10% of global CO2, the 0.2s, 0.3s, 0.4s will really add up when it comes to scaling. In terms of certification, we're working with businesses like Carbon Trust, so we can certify our measurement and our output to lead towards scientific-based targets and to lead towards potentially carbon offsets in the future as well. Another side benefit of what we could potentially provide here is, with a black box for concrete. Just like when you drive a car, if you have a black box on there, if the insurer sees you're driving well and it's good, your insurance premium comes down. Same with concrete. If they see that you're pouring well and it's all in spec and 100% of it is covered, your insurance premium might come down. And the other thing that we've seen is that ready-mix companies often self-insure up to £20 million, because no insurance companies will really touch that. And there's a lot of claims in there. So we could actually take that burden away from the ready-mix companies and have an insurance product that is for those small claims, because we have the data to power that. And it's worked in lots of other industries, in refrigerated shipping over the oceans. There's temperature gauges that make sure the fish is okay. It's the same principle applied to the perishable good, which in this case is concrete. Future use cases. So we're developing proprietary volume sensors on the truck, which will tell us the volume of concrete that is discharged during a pour, which in turn can tell us the volume of concrete left in the drum after a pour. So this will tell us how much concrete is potentially being returned to the batch plant or wasted, which helps with our CO2 footprint. It helps tracking waste, and ultimately it might help us find a use for that concrete somewhere else. But one of the really exciting things that we believe this can enable is actually the blending of concrete. So using our quality data, because we know the quality and the slump of the concrete in the truck, and our volume data, we know how much is in the truck. Our technology has the potential to enable the blending of return surplus concrete that's already in the drum with freshly newly batched concrete. Now, yes, there's a regulatory barrier and a standards barrier to be overcome there, but standards can be developed in 12 to 18 months. And providing we can evidence that what we are enabling is safe, compliant, and fine to go back out to the job site with the reblended concrete on top, that's a really exciting development, because that will just reduce all surplus and all waste concrete in a foul swoop, essentially. There'll obviously be some potential parameters around that about what it can and can't be used for, but rather than trying to find a spurious use for surplus concrete, such as a blinding layer, we can actually put it back into a high value use case and stop it going to landfill, essentially. We've developed proprietary temperature sensors for the truck as well, which give us both real-time ambient temperature and real-time concrete temperature. This will, instantly give digital acceptance for temperature when it arrives to site. So there's no manual temperature test required. Instead of having to dip your probe in the concrete, you've already got the result there. So that speeds time, saves man hours. And what it really will enable us to do, if you think about when you're pouring in extreme temperatures, we were in Italy with a customer last week in 36 degrees. If you're in Canada at 2 degrees, traditional logic would say, oh, it's too hot to pour. Well, is it? Because what is the temperature of the concrete? And we can understand that now. So we may be able to allow more pours in more extreme temperatures, both hot and cold, with the real-time temperature of the actual concrete in the drum. The other exciting thing that we're moving towards, and we're looking to secure a grant against, is mix optimization. So having this real-time feedback loop with the batch plant leads to more consistent batching, which will ultimately enable a water cement ratio optimization. And when you're talking about cement being 6% of global CO2 alone, having that, saving 5-10% of water cement ratio is a huge output. And what we're seeing and what we're hearing is, the designs are overspec'd with cement when they are designed, and then it's also overspec'd at batching as well, because no one wants to see concrete that's not strong enough go in the ground. With our data-rich environment, we can actually, with confidence, say, no, we don't need to put this much cement in here. We can start to reduce that and optimize it. And what does that lead to? It leads to a reduction of cement per cubic meter, and it leads to a reduction of CO2. In terms of what we're doing and who we're working with, we've been partnering with HS2 for 2 years now, and we're partnering with Holcim in a couple of countries in Europe, and we've been working with Cemex a lot in London and on HS2. They both really believe in the product, and we're scaling all the time with them and getting on more and more trucks in more and more locations. And we've sat with them every step of the way to really understand how this works. And where we're at now is we're starting to work with some of the joint ventures on HS2 as well to understand what this means for the contractors and tier ones. And the next step of this journey would be to start to speak with the designers of the world as well, to understand what our data can do for them at the design phase. And what you can see on the truck here, that's our cloud box. So that's the brain, that's the unit that sends the data to the cloud. And you can just see on the front of the drum behind the HS2 logo, that's our speed ring. So that's a component of one of the sensors on the truck that we deploy. But why are we doing all this? And what we're really doing this for is, we want huge impact. What we want to do is, if we're on every truck on the planet, not only will we improve concrete quality globally and build better things, we will enable CO2 reduction up to 1% globally, saving 500 million tons of waste, and it will save the industry literally billions of that waste, and obviously with the efficiency of the cement as well. And that's me, and I'm happy to take any questions. Thank you.
Thank you very much, Phil. It's so exciting. It takes very many.
There was a lot of information there, so it's quite a lot to get through. So yeah, happy to take any questions.
You did very well. You did very well. No, thank you very much. And I'm particularly pleased to see, it's a sort of shining. It's a transparency, isn't it, in that, and a real means of collecting and sharing data for all to move everything in a positive direction, which I think for me, that's what I find very exciting about the whole thing. Now, we have got a question here, which I think is really well worth unpacking, is to explain a little bit more about the actual process of digital testing. So how does that actually work?
Yeah, so if you think of a manual slump test, you are on site and you are putting concrete in a cone, you're lifting it up and you're seeing how far that slumps down. So that's a measure of viscosity, workability. What we do is we infer the same measurement in the back of the concrete truck. So what we're doing here is we're effectively turning the concrete drum into a rheometer. And the same test that the slump test shows how far it slumps, we're feeling the concrete. So we can feel with our sensors the viscosity and the workability of that concrete. And through our calibration campaigns, what we do is we use our system to say, okay, we think this is a 22 slump. And we then do a manual slump test, or lots of them, alongside our digital tests, and we see how we match up to the real world environment. And we've done that over the last 2 years to a point now where we're very confident that our digital readout is the same as a manual test. What this means in the context of HS2 is, instead of them having to have a manual tester test every single load of concrete that comes onto their site, HS2 have said, wait a minute, well, can you just give us a digital readout of what you say the slump in the truck is? Because they already have assurance that our readout will match the manual slump test. So the goal is to replace them and then to pin that to a new digital testing standard. So that's what we mean by digital testing: digital slump testing and digital flow testing. So all the way from your S1s to your slump flow mixes and your flows. And the goal is to cover all of those.
And so the sensors are inside the truck. Does it vary according to the type of truck? And, when you say that, you have a sense of it, does that sense vary with a different fleet or age of truck? How does that work?
Yeah, so this is one of the interesting challenges. So our sensors are all on the outside of the truck, and they are very, very lightweight, and they essentially feel the drum spinning. And most of the trucks are a similar configuration. There may be slightly different gearboxes or slightly different, space between the drum and the gearbox. So there are slight variants, yes. So what happens is we calibrate by truck types. So if you have a ubiquitous fleet with all the same trucks, you're going to be good. We might only have to calibrate on 2 trucks. If you have different fleets, we might have to calibrate on 2 per 100 type of truck. And then we get to a level of accuracy that we're pretty comfortable with. And so far, we've not really seen many trucks that really kind of break the system or are workable, because we've just been retrofitting at the moment. But ultimately, if you think about it, our model at scale is to work with the OEMs, to work with Liebherr, to work with McPhee, to work with Schwingstetter, and have our kit. You can order a truck with Cloud Cycle installed and Cloud Cycle ready.
Yeah, okay, no, that makes sense. So at the moment, when you're saying that calibration process, that happens real time with projects, so you match against slump tests that are produced, or is that a sort of pre-prep process?
It's very much pre-prep. So what we do is we look at the concrete types for each specific customer. So there's no point us calibrating on a concrete that is 1% of what they sell. So we'd normally go, whatever they sell the most of, we'll do that. And then if they're working on HS2, for example, they might say, oh, this is a brand new mix for us, and we're really nervous about making sure that it's perfect. Let's start on that one as well. So it will either be a very high value mix for them at a really marquee project, or it will be just like their cooking concrete that they produce ubiquitously, and they want to make sure that they're the best at doing that. So there's 2 approaches to that. But ultimately, we are customer led, so they will give us their mix list and tell us what they want to test on initially. But the ultimate goal here is to have an S4 at one business in the US, and we can infer that on an S4 in a business in Asia, and we can basically, the model can work out that they're basically the same. So the calibration will get less and less over time.
Okay, excellent. So who owns that data? You've muted yourself.
Oh, sorry. So any data that is supplied to us by our customers is owned by them. Any data that we produce, we would control. So it's not like we can do anything we like with that data, but we would own and control that on our servers. So that's how we kind of broadly frame it. Anything that's provided to us, our customers own, whether it be a tier 1 client or a RMC, anything that we create belongs to Cloud Cycle. obviously with lots of caveats around that and how we can share it and where we can share it. We take data security very seriously. It's one of the biggest challenges of the business, actually.
Yeah, I'm sure it is. Yeah, absolutely. And then I think the final question we're going to ask is about the longevity of those sensors, and how long are they? Do you anticipate them lasting? What's the sort of anticipated replacement cycle? The ease of them being replaced?
Yeah, so our system is very lightweight on purpose. So to do a full install is only 1 hour. And basically, if you think about a concrete truck, sorry, my dog just barked in the background. If you think about a concrete truck, they are replaced every 7 years, and our sensors will last as long as the truck, essentially. And then we can replace them and have new ones, or if we have an upgrade, we can deploy and upgrade them without any issues.
So thanks, Phil. That was an excellent talk. And thank you for everybody's questions. Please do look out for the other recordings and innovations featured in this Fresh Concrete series. The recordings are available on both the Building Centre and the Concrete Centre websites, as well as a whole host of other information related to innovation, but also day-to-day guidance to help you get the best out of concrete. Thank you very much.